Welcome to the Bug Hunters Café. Have a seat anywhere.
Thanks. Oh, hey, Jason.
Hey, Bojan, I didn't know you hung out here.
Oh yeah, one of the janitor's closets at the office leads right to the alley. How about you?
That coat closet over there.
Ah, it wasn't there yesterday.
It wouldn't be, that's my ride. It'll disappear when I leave.
So strange.
You want me to get you something? The coffee's provided by Soft Terrific.
Yes, I'm gonna get double espresso without any coffee.
Double espresso without any... How do you even make that?
I got you.
Marta can make it. She knows what I'll have.
She's terrific. I've been learning JavaScript over the past few weeks. I'm really not sure what I've gotten myself into here. I'm known for my hatred of JavaScript, but I'm learning it.
Yeah. I feel great empathy for you. During my career, I think 12 years ago, before there was debugging in JavaScript with that sort of language, and as we are already here, that was one of my first bugs that I debugged outside of university. So how I would debug it is basically I wouldn't even use console print statements like kids these days. I would just show up the dialog box with the value variable.
Honestly, you can give any programmer a $2,000 debugging tool, and they will still use print statements. I still use print statements. I even put a big old missive in Dead Simple Python, ticked off half my technical editor, said, get out of the habit of using print statements for debugging. Use the debugger. Technical editors are like, I take this as a personal attack, thank you. It's true, I mean, we all do it. It's probably not the best use of time, but, it's the easiest.
Yeah, I mean, if people didn't want us to use print statements, they wouldn't be in the programming language.
Yeah, exactly. Hello World's the first thing we write, and then our professors all insult us by saying, you've just written your first piece of software. No, I haven't. There's a profound difference between working code and software, thank you.
Yeah. I remember that progression curve on my college. It was basically first class, it was, okay, write the print statement. Yay! Second class, now declare an array. Yay! Third class, now write the full functional learning calculator. And also our assistant that is professional tester is gonna mark your work. And I was like, what?
Yeah, it's basically draw some circles, step 2, draw the rest of the stupid owl. That meme.
Absolutely. In my university we were graded from 5 to 10. And the highest mark on that specific assignment was 6. That's the passing grade. Barely passing grade.
Yikes. Yeah, I've most of my career, I've learned things kind of self-taught, so I learned... It was kind of funny, someone posted on Twitter the other day a bunch of those old Works books. You remember the Works books? What is it, WORX? Little red, really thick red books with yellow titles. Anyway, that's what I learned from, and I saw the VB script book on the shelf. I'm like, yes, it's my first language. I hated it, but it worked. It did. I started with VB script, and then I moved on to VB.net, and then I moved on to Python, where I have been ever since. Beyond that, I picked up ActionScript and C++, and more languages than I can count. So anyway, now I'm just, brushing up on JavaScript, which is not really unfamiliar territory since I already know ActionScript. Flash just died officially. It was on death row as of 2012. I know from one of the Adobe developers, but it finally died. Was it last week? But yeah, I mean, I did ActionScript back in the day, so JavaScript's not a far jump from ActionScript. I like to say that ActionScript is the alien love child of JavaScript and Satan. So it's just kind of familiarizing myself with some of the newer syntax with JavaScript, like ES 2020 and whatnot, and why you do things in the newer versions. the particular way you do let over var and all that. And so to practice it, I've been using codeandgame.com, which is a lot of fun. It's a great way to get some practice in. But I was just trying to implement a pathfinding algorithm. I can never pronounce it. Diskestra's algorithm. Oh, whatever. Breadth first.
Yeah.
Pathfinding. I was trying to implement it, and I spent an hour trying to figure out why is this not working. And I wound up starting over and rewriting it, still had the same problem. Like, what is going on? And then I discovered if you're trying to implement this algorithm, it does not help if you're only looking at the diagonally connected nodes. I wasn't looking up, down, left, right. I was looking diagonal. It's like, no, of course that's not going to work. I'm trying to figure out why I was doing the console log. It's like, why is every other node not being visited? Well, visiting it in an X shape is just not going to get you where you want to go. It took me an hour to figure that one out. So that was only about 100 lines of code. So sometimes these bugs hide in the most unexpected places, but when you find it, it's almost insulting how obvious it actually is.
Yeah, I have my first bug ever was you mentioned Flash earlier. So basically, I was young and I needed the money. So only legal thing as a 16-year that I could do for that was to write a website using Flash. Now, at the time, after I was done with development of the website, I had a problem. Basically, nobody was visiting it except me. And I was trying to debug it, so I called my brother, and he told me, "That's insane! Why would anybody visit it?" And we couldn't figure it out. Now, years later, I'm looking at it and hang a 5 megabyte Flash animation that was playing at full sound without a possibility to mute on dial-up was probably something related to that.
Maybe.
I'm not sure.
Maybe a little.
So yeah, sometimes we create bugs that are not inside of the code.
I was asked recently, what do you call a bug? Well, what do you consider to be a bug? Because apparently there's some disagreement about this in the tech field. What is a bug? And my answer to that question is a bug is any behavior which is surprising to the user. It doesn't matter whether you intended it to act that way or not. It doesn't matter whether it's in the spec. It doesn't matter whether it was properly designed according to your plans. If it's surprising to the user, it is a bug. Because we have to design software for people. Now, I do have to put a condition on there. I would say surprising to the average user, because there's always that one weird person that expects the save button to have fireworks. There's fringe cases everywhere. People are weird. But if the average user keeps using the program in a particular way and expects A, B, C to yield result D, and they keep getting result Z, then of course it's going to be confusing to them, and they're going to file a bug report. And the worst thing in the world to put on a bug report like that is won't fix. I hate the term won't fix in a bug tracker.
Yeah, and I'm going to admit it right away. I was like that when I started. I think 3 or 6 months after I started, that's the most dangerous territory, because I know just enough to be dangerous. And that was basically like, oh, user is stupid. Why doesn't he understand my perfectly logically named algorithms and variable names?
Yeah.
Like, he's complaining about error, x is not equal to 10 or something like that. Like, well, it's perfectly simple. You need to open this up and change it.
Yeah.
And
cognitive availability bias, I believe, is what that's called. It's like, it's in my mind.
Yeah, took me 2 companies to learn that.
Yeah, yikes. Well, and there's some developers who never learn, and I think that's the source of some of the other bugs. I am a bit controversial in some circles because I advocate strongly for commenting, and there are a lot of people who will tell you, oh, commenting is evil, commenting is bad, don't comment. I'll put a huge disclaimer on it and say, don't comment what the code is doing. Please don't tell me what the code is doing. I can tell from the syntax what the code is doing. Yes, it's a for loop. Don't tell me that. But what we need to be doing is we need to be commenting why the code is there. What is the expected end result of the code? That, I think, should always be commented, even if it's bright, blazingly obvious to us, because the fact is, we do have that cognitive bias where it makes sense to us at the time, and we don't realize it doesn't make sense to anyone else. So I tell people, over-comment. Every single logical statement should have an accompanying comment describing what you're intending that code to do. Weeks later, or months later, or when somebody who does not know the code at all reviews it, you can go through those, and then you can remove the obvious statements because, well, yeah, it's obvious this is printing out the greeting to the user because it's print hello user. Okay, you don't need that comment. So then you can remove that comment, but only once that decision can be made by someone who does not have the code fresh in their brain. Because we do take for granted how much it makes sense to us, but not to anyone else.
I would just say that I have many lovely discussions with my previous iterations. When I look at the code and I was like, what idiot wrote this? And why is there no comments? So, in order to have a nice discussion with my future self, I always try to use long names for functions. I learned it's better to have a long function name than to have something that's not easily understandable. There's no penalty for that.
Sure, yeah. Of course, there does have to be a limit because, I mean, I found this one link that has all these function names which are, like, stretching on for, like, 20, 30, 40 words. Facebook's guilty of some of those. I believe that comments and self-commenting code have to go together. One cannot replace another. Never send a comment to do a name's job, but never send a name to do a comment's job. The comment should describe what the function's going to do or what the variable is supposed to be storing. The comment is there to describe why it's even doing it. Although I will say a good name can be very helpful, because if you have to use the word and anywhere in your function name, you need to split that into two functions. You know, that single responsibility principle.
Yeah. What's the name of that book? It's not Effective Coder? Elegant Coder?
No, hopefully not Clean Code. Are you talking about Clean Code?
Clean Code. Yeah.
Yeah. Well, I have a love-hate relationship with Robert Martin's work. You know, at the risk of alienating half the programming world, I don't like the guy. But that's more or less for his inability to distinguish between his opinion and reality. And unfortunately, I discovered in the last couple of years, he's also a bigot to all end. But, you know, he has some good ideas. I just think the principles of clean coding are best filtered through the minds of people who aren't quite as locked into their own... you know, are quite as obsessed with their own reflection as Robert Martin is, because one person who, and the reason I say that, I'm not trying to be uncharitable to Robert Martin, understand, you know, but there, as one person put it, clean code contains some good advice and some terrible advice, and you really have to apply your own discernment to know the difference. Well, the problem is the average developer doesn't have that discernment. If they did, they wouldn't be reading the book. So the only way you can know which of his advice is good and which isn't is to test it out. Well, it's been tested out by a lot of people who then rehash clean code in their own writing, their own blog posts or Pluralsight courses or whatever. And so it would be better to go to them to get that information, because the book can be very treacherous territory in terms of, you know, some good ideas and some absolutely horrible ideas, and absolutely no delineation between the two. Sorry to anybody who likes clean coding, and probably just alienated half the people out there, you know, the first round. But
well, we're here to share opinions.
Indeed.
And hopefully we'll learn from them. When I was starting, clean code gave me some pretty good advice. Now, that was several years ago, so I haven't reread it. So those terrible parts, I didn't notice them, because probably I lacked experience or something else. But for me, it was a useful book.
Yeah, and I can see that. I still don't recommend it, but it's you know, I can understand that perspective. I think the other part too is, you know, it's not really going to be a career breaker whether you read it or don't read it, you know. And I think that's the important thing to remember, is that someone could go their entire career and never read that book and actually be just fine. But if you do read the book, or honestly pick up on any other methodology, whether it's clean code or solid or design patterns or anything out there, agile, anything related to coding, even my own standards, you pick up on any of that, you have to bring your own common sense to the table, because common sense is not included. I worked on a code base, worked with a code base, wasn't working on it. I worked with a code base that was followed the solid principles of object-oriented programming flawlessly. And yet it was the single worst code base I ever saw in my life, because they had every single object in the entire very large framework inheriting from every other object. To the point that, 250 objects down this hierarchy, some plugin that you absolutely relied on this inheritance chain all the way back to A, and it followed solid, but if one little detail changed in A, it broke everything else. And that might not have been so bad if they documented things, but they didn't document the changes. Ever. So you just had to muck about in this 200, class inheritance structure. Oh, they also adjusted everything so that you couldn't do composition. They made composition into a form of inheritance just to make things even better. So it was a complete pile of spaghetti, and it's completely impossible to do anything. Every single release, minor release, invalidated everything written about every prior release. It was horrible. And this is a major framework that's in use out there. So,
dear God,
yeah, you got to bring your brain. Common sense has to be included, because bugs happen when we do things and we don't know why we do them. Cargo cult programming.
Yeah,
that's a lot of bugs happen that way.
I'm gonna say I'm the first person guilty of that. It took me a long time to develop a common sense, and that's the first thing when I'm mentoring somebody is teach them to ask things why. Does this make sense? That's more important than the actual programming.
Yes.
To teach them to not trust me. I'm super happy when I'm working with a project with my mentee, and they called me out on some mistake I made, or asked me why I did that. It doesn't make sense, and they are usually right.
Yeah. Yeah, that's.
And for me, that's the greatest success: being able to point at my mistakes, not to take them as this is absolute truth. My mentor cannot make mistakes. No, I'm human. I'm gonna make mistakes all the time.
Yeah, if as a mentor myself, if I'm not making some of the biggest and most impressive mistakes in the company, there's something wrong. These are. Of course, I'm talking about coding mistakes, but my team knows you want to see some doozies. Look at my code, and I write consistently good code, passes tests, fairly stable. I'm very good at writing memory. We're working in C++ a lot. I'm very good at writing memory safe code on the first try. But, when you know the basics that well, that just sets you up to be able to make more impressive and more entertaining mistakes, honestly. And there are times where I get caught regularly. I have to tell you, there's some weird bugs too that hide. There's weird types of bugs. It's easy enough to fix a borer bug, as we call it. It's predictable. But there are other types of bugs out there. Actually, I had one a few months ago. I was working on some code with one of my interns, and he said, "You know what? Your sorting class is not compiling." I had written a sorting algorithm. I didn't invent the algorithm. I just wrote the implementation. But he said, "Yeah, it's not compiling." I'm like, "What do you mean it's not compiling? We've been using this for 5 years. We haven't changed it. 5 years. It had been in continuous use, in production." Anyway, he said, "No, it's not compiling." I was like, "I just compiled it today." And I hit the recompile button as he's telling me it's not working on his machine. I hit the recompile button. I have changed nothing. This is on the devel branch, our primary development branch. I have not changed a single line in that code or any of its dependencies. And it goes from compiling to breaking. And breaking so thoroughly that a casual inspection, I realized the code should have never compiled to begin with. That code has been compiling in violation of the laws of physics for 5 years. And it's not a compiler update either. It's just it was a 1 minute gap. Worked, didn't work. And the only thing that had changed was my internet pointed out that it wasn't working on his end, and I'm like, it's called a Schroden bug.
Schrodinger's code.
Yes. Yeah, it's actually called a Schroden bug. Yeah, I have seen 2 or 3 of these in the wild where someone observes that it's not working or shouldn't be working, and then it stops working for everybody until fixed. It actually broke on the CI. That had been building it up to that point. Like, how weird is that? So
yeah,
bugs are...
I'm gonna take that as multiverse is collapsing.
Yeah, absolutely.
Hi, Bug Hunters Café. Marta speaking. Oh yeah, we're open 24/7 at bughunters.cafe. You can also find us on Twitter, Instagram and Dev as Bug Hunters Café. No, we strictly bring your own time zone. We don't provide one. Hold on. Who gave the unicorn the double shot espresso?
My fault.
So many sparkles.
No, I actually, I am blessed with an immunity to the effects of caffeine. I can drink a pot of coffee and I can go straight to bed. It's one of, and I've talked to my doctor. It is not a tolerance. I literally can drink as much coffee as I want, and it never does anything to me. Now, if I drink a double shot Americano, which I did once in college, I will vibrate like a massage chair. But normal drip, I am peachy. So.
You're my solar opposite. Once, when I was in college, I drank a glass of coffee. I didn't sleep for 4 days. I prepared 500 books page for exam and I got 10. It's the marks grade. I learned everything. And since then, the most I had is just a sip of coffee and I'm awake for the whole day. But usually just the smell of coffee is enough for me. I'm like super sensitive to coffee.
Yeah, there you go. So what do you go for? Tea, usually?
Yeah. I'm the tea person.
Yeah, there's actually more tea. There's more caffeine in tea than coffee sometimes.
Yes, especially since I drink black tea. I have no scientific explanation. I know that black tea has more caffeine than coffee, but for some reason, coffee acts weird for me.
Yeah, how did that classic line go? Talking about some thick coffee. Drink 1 cup, you'll be awake drink 1 sip, you'll be awake all night. Drink 2 sips, you'll be awake for 3 days. Drink a whole cup, you won't blink in daylight. No, I like the meme though. This is programmers convert coffee to code. I feel like that's or in your case tea to code. But I think no amount of I love coffee. Coffee is the answer to anything. I like that coaster. That's good. I think the problem we run into sometimes though is that sometimes we're paying a little too close attention to our code, and we get what I call code blind. I don't know if this ever happens to you, but I get to where I've been working on the same code for so long that I can no longer see the obvious right in front of my face. I get some real glorious bugs then. It's
Yeah, that is why duck debugging exists.
Yeah. Rubber duck debugging. So you got your unicorn for that. I have Dr. Hooves here. My Little Pony. So I have him.
Oh, he's awesome.
Yeah, so basically a pony version of Doctor Who. That works. And then I also have this little fox here, this little stuffed fox. This was...
it's super cute.
Yeah, this actually used to belong to my very dear friend Chris Fraser, who I dedicated my programming book to. He was kind of like a dad to me, actually. But we connected over coding, in addition to many other things. And he was a COBOL programmer back in the day. He did punch card programming for the Army, and yeah, he passed away actually last February. So it's been it's been tough, but I anytime I'm working with older code, I oftentimes wind up thinking of him. He told me once the debugging that they had to do then, because of course back then the only way you could debug was with the blinking lights. You had to take your punch cards and you had to put them in the queue to run, and then you'd have to look at the output. Or if you're running it yourself, you get to watch the little lights on the console, and you had to figure out from the sequence of lights, what's wrong with your code. We think what we do is hard.
Yeah. I got nothing to compete with that.
Yeah.
Right now we have fancy debugging tools, logging, all that stuff.
And yeah, we always, like we mentioned earlier, we always wind up going back to the print statements. I wound up just accepting that reality over in C++. I built little promotion here, but I built something called IOSqueak in C++, which allows me to actually dump the ROM memory and memory addresses of any object or pointer onto the terminal, and it formats it, and it does all the nice spacing and everything, converts it down to hexadecimal. It's really nice. So it's just because printing stuff with cout gets really difficult because you just wind up with numbers most of the time. So, this way it retains the data about the type. You get like true and false on your Boolean, or you get a hexadecimal dump instead of a decimal dump for, raw memory, stuff like that. And it does make debugging via print statement a lot easier.
Yeah, it's been a while since I worked with low-level languages. I know during the university courses we had one whole course on assembler, and that was super fun because then you worked with a register on the CPU, and that was the whole memory.
Yes. Yeah. I've done a little bit of assembly. I wrote a test library and had to work with some x86 there, and that was a good time. I enjoy low level. I think I enjoy it more than I enjoy high level. I enjoy getting down into memory, and I'm the guy who actually enjoys debugging seg faults. And I mentioned this in the C++ chat room, and the guy's like, oh, it's easy with Valgrind. It's like, oh no, I like it when it stumps Valgrind. And anyway, he's like, wait a minute, you were serious? I think you were kidding. Like, no, I actually enjoy debugging seg faults.
Segmentation faults were the nightmare of my first year on college. Oh man, do you know how many of them I got? Basically, okay, I'm gonna assign an array and I'm gonna access outside of that array. And then I wrote 20 lines of code. Took me 4 hours to get what's happening there.
Yeah, it gets weird. And it's funny because people say, well, that's why I like working with higher level languages, because you don't get memory errors. Yeah, you do. You get memory errors in every single language on the planet because every language is built on top of another language. Usually C, sometimes Rust or C++. Sometimes some crazy person will just do it in assembly, but it's always got to be written on top of something else. So you have these layers of abstraction that are stacked one on top of another, and this is why it's so helpful to understand why your language of choice does things the way they do things. Because abstraction is not there to save thinking, it's there to save typing.
Absolutely.
Because it's when that abstraction breaks that you get bugs. It's just a simple memory error down here in C, very easy to fix if you were just in C, but once it percolates up to, your JavaScript engine or to Python or what have you, now the computer's dancing on the rooftops in its knickers, and you cannot figure out why. It's a good rule of thumb. If it's weird, it's memory. Every single time. If it's weird, it's memory. It's been my adage for the past, 8 years, and it's always proven true.
Oh, I think also lots of Python programmers don't realize how many Fortran and C++ libraries are they using in everyday life, because Python makes it so easy to just import modules from other languages.
Yeah. Sometimes those imports are actually importing something out of C and you don't even realize it, until you look at the documentation. It's like, oh, this is a C extension. Yeah, it's I think the biggest problem when it comes to memory that people have, when it comes to computer memory anyway, is that there's no such thing as magical when it comes to code, when it comes to resizing, and variables and data types, there's no such thing as magic. It has to be figured out by the computer at some stage in the process. And we get into this habit of thinking, well, my list is just going to magically resize to accommodate the space. Because that's the way most languages do it. You know, your JavaScript arrays and your Python lists and what have you, they change size depending on what it is you're putting into it. But the fact is, at some point, you're going to have to tell the computer how large that thing is. And it's got to make room for exactly that much space. And then when you exceed that amount of space, it's going to have to go back and find a new place for that data structure. And that has a cost to performance. This is the whole issue of dynamic allocation, and when we run into performance issues, that is one of the biggest culprits. Someone pointed out to me that the address bar in Chrome is particularly insidious because it reallocates the entire string storing the contents of the address bar. Each time you type a character, it reallocates. Which is insane because appending to a data structure is, that's 01 usually. But appending to a data structure where you also have to reallocate it, that can take anywhere between 10 and hundreds of CPU cycles. Whereas, when's the last time you saw a URL that was over 1,000 characters? It's not very often. Sometimes it happens, but if you just pre-allocate, something like a 500 character array, when you run out of space for that, jump to 1,000. When you run out of space for that, jump to 2,000. It's a very simple pattern. A little thought can go a long way. We say premature optimization is the root of all evil, but I would add to that in this modern age that not thinking about optimization at all accounts for the other 100% of evil. We're 200% evil now in our code.
Yeah, well, Google is pretty interesting as a company because that issue that you mentioned, they have that on the much higher level with their products, where they are basically reinventing the wheel constantly instead of using and thinking in advance. I mean, it's pretty famous death by Google for lots of services that they kill. And then reinvent. I think they have like 4 or 5 messaging applications at the moment.
Oh, yeah, I know. They always have more of them, too. I think part of it is FANG arrogance, F-A-A-N-G. The large tech companies, they have this cockiness about them that, well, we can do it better. We're smart. We can do it better. Maybe they can, but more often than not, no, you can't. Or the amount of work you're going to have to put into actually doing it better is not going to be worth it. And this is from the guy who beat standard vector in terms of dynamically allocated array performance. Okay, so I've reinvented the wheel and actually gotten away with it, but there's got to be a really good reason to do it. And just because, well, I think I could do it better than the other guy is not a good enough reason. But we have that habit. I think is one of the reasons that Microsoft is it seems to be doing better these days than it did. Some people will disagree with that assessment, but they seem to be becoming more stable. I mean, their antivirus software actually just passed the independent lab tests with an A+ for the first time ever a couple years ago. So their code quality seems to be improving, and I think part of that is their push towards open source. The idea that, okay, instead of just reinventing the wheel all the time, maybe there's stuff out there that we can actually pick up on, use in a mutually beneficial way, and then build on top of, instead of just trying to reinvent everything all the time.
Yeah. Microsoft today is completely different beast. I mean, when I first heard, .NET is gonna be open source, I was, what? I thought it was April joke. Well, but no worries, we still have our dear Amazon, Google, and the king of them all, Oracle.
Don't forget Facebook.
That's a completely different category of evil.
Yeah, arguably. Well, technically, all of them are in the same business, world domination. But, I think the mistake people also tend to make at the same time as they tend to think, okay, well, because the big company does it this way, we should do it that way. How often do you hear that? It's like, well, Google does it that way. It's like, yeah, Google has 10,000 employees.
I have a story about that also. Yeah, so this is the bug that was not in the code. In my first company where I was working as a CEO, I heard all the great things about how Valve is organizing stuff with horizontal hierarchy, people choosing their projects and stuff like that. So I thought, if Valve is doing it, we should do it as well. And that led to tons of problems with projects not being finished and people not being able to sync up because everybody was working different time. Completely disastrous stuff. Yeah, and I think that was the first time I learned that you should use common sense. Valve can do it because they have Steam as a main source of income. You can't do that in startup. You need some sort of structure and organization.
Sure. Yeah. I was reading this really good article about glue. Glue work is what a lot of really communication-oriented developers tend to do. They get into an organization, they see the places where things are sticking, documentation isn't quite good, project direction is unclear, bunch of bugs that are unaudited, etc. And so they find ways to improve the process, and they get the rest of their teammates unstuck, but that takes time away from code, and so then when promotion time rolls around, then the bosses look at that and go, okay, well, you wrote all this great code, so you get promoted, and you made the network more stable, so you get promoted, and the person who did all the glue work that made all that possible is going, well, what about me? Well, you didn't do enough technical work. And, you know, the article did a really good job of saying, hey, you know, if you're in that situation, you have to recognize what you actually need to do to get where you want to go, and if that means you have to let some things fall apart around your ears because it's not your job, do that. When you stop doing all that glue work, they will eventually recognize, oh, she was keeping it together. But from the flip side of that, building on what you were saying, I think project leaders really need to get better at recognizing bugs in teams. Because you can have bugs that transcend the code, and there's that old tongue-in-cheek law. I can't remember the name of the law now, but it said if you have a 2-part team, then you will have a 2-pass compiler. The project's going to take on the attributes of the team. So if the team is inherently flawed in their organization, the code is going to be inherently flawed in its structure.
That is 100% true. As this is my third company, most of the time, as much as I hate to admit it, I was the cause of those bugs.
Yeah, I've had my fair share too.
Yeah. I mean, it was a learning curve, and I'm still working today to improve myself in that, because soft skills are underrated. I know lots of my colleagues, when we were learning, they were like, oh, I'm gonna be a programmer, I'm not gonna have to talk to people, I'm just gonna program stuff.
Well, it's like Joel Spolsky said, communication is more important than technical skills.
Yeah. And those are the skills that matter the most. Like 90% of the time you're gonna spend communicating with other people.
Yeah. I like to describe a programmer as a translator between humans and machines. We have to take human thought and we have to translate it into machine language, and then we have to take machine output and translate it back to human thought. So ask any language translator and they will tell you, if you're going to be a translator for, say, you know, Russian to English, you have to be fluent in both Russian and English. You can't be fluent in one and kind of, sort of, somewhat familiar with the other. It's not going to work. You have to understand all the subtleties of both languages in order to perform that translation, or you're going to get the wrong message.
Absolutely. It's very easy when you work with technical persons, but most of the time your clients are not going to be technical person, and what they are saying is not the same thing that they want and what they need. So you need to decipher that. You need to compile the request into actual request, and then compile that into code.
Sure, exactly. And I think that's inherently why debugging is so hard. Because we are still human. Even though we understand machine language kind of sort of ish, some better than others, we're still human beings. We don't think in ones and zeros at the end of the day. We still think in human thought. And so it's a little bit like someone from, say an Athabascan from like Alaska trying to describe to someone who lives in the jungles of the Amazon how to build an igloo. You know, good luck, because they don't speak the same language. They don't have any of the common experiences, or very few. And even if you were to take that person out of the Amazon rainforest and drop them off now in the in winter in Alaska, and have the Athabascan try to tell them verbally only, because that's what code is. It's almost like verbally telling. Okay, build an igloo. I'm going to explain to you how to build an igloo. Without a translator who knows the subtleties of both of those languages, they're going to try their best to explain it, you know, with the little bits of language that they know. But they have no way of knowing whether or not the other person, the person from the Amazon basin, is building that igloo correctly until they look at it. But the problem with coding is we don't get to see our work until we hit the compile button, or we load it in the web browser or whatever. And so we have to figure out what went wrong after the fact. So it's almost like now you make that whole situation worse, and the Athabascan's trying to explain it to the person from the Amazon over the phone. Flies out, takes a look at the igloo, goes, no. Goes back, explains over the phone again. It's just the picture is one of utter futility, but that's what we do all day. The machine cannot run while it's open, basically. And, I mean, that's where a debugger is so helpful, is it lets us kind of bore a little hole in the machine and look in and see a little corner of it, but the machine cannot run while we're looking at it. And so it's hard to figure out what's going wrong when you can't see the moving parts.
Yeah, computers are very shy.
You open the box while it's running, it lets out all the magic smoke.
Yeah, but on the other side, the product of that code, you need to translate that into business value, into something that client is going to understand. I know, usually, when I work with client on some machine learning project, I have a hard time explaining them, oh, you got that model working in the notebook. Okay, so we have that done. No. Now that needs to go on the website. I need to create Python code for that. There are some optimization to be done. But we have it running now. I can see it on my screen. No, this is the completely different thing. Explaining the difference between prototype and the actual product. That's very difficult because on one hand they can see the solution, it's there. Mm-hmm. And you have to explain them that's not the solution, even if that is the correct response.
Yeah. Well, and of course that's why a lot of people coming from college are so woefully underprepared for work in the industry, is because they spend their entire time building prototypes. That is the only thing you build in most college programs, is a bunch of prototypes. And some of those prototypes might be large enough to feel like real projects, and on occasion you wind up at a college where you're going to ship a senior project that actually is an app. But you spend all your time building these little Lego models, and then you try and scale that up to, you know, human-sized engineering. And as Gerald Weinberg once famously said, if programmers built programs the way, or if builders built buildings the way that programmers built programs, then the first woodpecker that came along would destroy civilization. Because we're scaling up all these processes that never actually work to begin with, but they look good on paper, and we can make little tiny prototypes with them, and we scale it up to try and build the Brooklyn Bridge, and then we suddenly realize that a Lego brick is not capable of holding a car. You know, it had never occurred to us before, because we'd never built anything to that scale. Which just goes to show, you know, if if someone is in college and they want to get into this field, the best thing they can do is to get out of the matrix as quick as possible and get into some actual projects. Get into open source, start working on real projects, because it becomes very evident very quickly everything they learned in class does not work in the real world.
Oh yeah. But allowed to say college is very good for teaching you how to learn. But for the actual stuff, you need experience. Especially since usually in college, when you have a team, that's completely different dynamic than when you have a team in work environment.
Oh yeah, absolutely. You know, the dreaded group project that everybody hates.
Yeah, I mean it's completely different when you're working to get your bread on the table. People are not gonna slack off most of the time.
Most of the time, yeah. I'm convinced the college group project was invented by the Spanish Inquisition.
Most likely.
Yeah, most likely. But no, getting actual experience is important, and it's funny because I work with universities. I run an internship program, and I know some professors, and they keep telling their students, look, what you're learning here does not translate. You have to have real-world experience. And the students all hear this, and it goes in one ear and out the other. And then they apply for jobs at my internship, and it's I have a 50% washout rate, and it's not because of how we do things, because the people who do finish are very well prepared, and they wind up moving on to, you know, full-time positions at software companies, you know, early mid-level positions, and they do very well for themselves. But the reason that turnover rate is so high is because of the number of students that come in and think this is going to be an easy way to make $100,000 a year, you know, going rate in the U.S. It's not. This is one of the only reason that this is the second highest grossing career after medicine is because this is one of the hardest careers on the planet. You know, this is not easy, and you can't do toy programs get paid $100,000. You get paid $100,000 a year because you can take a stack trace and a server that's still smoldering from last night's fire and figure out where the bug in the code is. That's why he gets paid so much. Debugging is like 90% of the job.
Oh yeah, absolutely. And there's nothing like, let's do a deployment on a Friday or before the holidays. I love those stuff.
Absolutely, and then the computer just goes, yeah, we're going to have some fun tonight. Now, anybody ever tries to tell me computers aren't sentient, I'm going to be like, yeah, singularity's come and gone, man. These things are out to get us.
Yeah, I'm not sure about computers, but about printers, yeah. They can smell your fear.
Yeah, debugging a printer, I can't bring myself to do it because I'm a confirmed Lutheran, and I have an issue with the dark arts. I cannot ethically participate in that. Leave that to others. I will not do it. Oh dear. Throw some holy water at it, it'll be fine. Hey, we should do this more often. Maybe get some of our coding friends to come talk bugs.
Absolutely. We should get everybody here, not just our coding friends. I think almost everybody had a situation where they debugged something, even if they didn't know they were debugging it.
There's a lot of unexpected hats in the tech world, definitely.
Hopefully, we'll get to see all sides of this debugging thing we're talking about.
Absolutely, and of course, I'll keep writing down some of my doozies as I'm learning this new JavaScript version and practicing algorithms with it. I'm just grateful that one bug was in a 200-line coding challenge and not in a 20,000-line production project, because I probably would have lost my mind otherwise.
Hi, Bug Hunters Café. Marta speaking. Our location? Sure. You can find us at bughunters.cafe. And on Twitter, Instagram and Dev as Bug Hunters Café. Well, that's just it. We don't know where all the portals to the cafe are. You usually find one when you're not looking for it. Well, you'll have to take it up with the unicorn. He likes paradoxes. Yes, it's an actual unicorn. Our music is provided by audionautics.com. We have the link on our website. You're welcome. We hope to see you soon.